I'm also a Woman of Code Python track lead. In case you wanna follow me on Slack, feel free to do so. So today's agenda. So we would be talking about what is standard library. This is the third part of the standard library series. I believe this is the last part. We will be exploring two main libraries. One is collections and one is itertools, and how to and then we'll be talking about, before we goes to hands-on coding, we will be telling you the setup and the requirements. So what is Python standard library in case the first time coming in? It offers a lot of built-in functionality, so it's a standard library. Basically, when you install Python, it's there. You don't need to install pip install on the extra library. So it's a huge collection of utilities that you can actually use. We previously used couple ones on the previous section. So if you're first time here, feel free to check it out. So collections, the library collections. So it's a built-in Python module, like I said, that implements specialized container data types, providing alternatives to Python's general purpose built-in containers such as dictionary, list, set, and tuple. A container, what is a container? It's an object that is used to store different objects that provides a way to access it, these container objects, and iterate over them. So we will be playing one of the most popular function that is called counter, module. So counter creates an order collection where the elements and their respective counts are stored as a dictionary. And we will be playing when you do hands-on coding, we will be playing these functions from the counter modules, but we will be going over once we go to live coding. So the second module we will be doing, our second function we'll be doing is the DQ. It's actually a very fast alternative for Python lists. It allows operation from both sides of the letterbox. Default date is also very, very popular as well. It's similar to a regular dictionary, but it actually helps you to access try to access the profile they don't have exist yet. So, and also for example, if you want to create a dictionary, but you want to create an empty dictionary, using the default date will be helping you to have a structure without the key and values. Also, another popular one is the order dictionary, similar to a regular dictionary, but remembers the order of the keys in which they were first inserted. So it's ordered. And the other types of dictionary do not store keys in an order. So you have, and then one of them is a name tuple. It returns a tuple-like object with name views. And these views attributes are accessible by lookup as well by index. Chain mat is one function that encapsulates many dictionaries in one unit. So if you guys are still confused, what is it? Don't worry about it first. Once you get to the hands-on, it will be more familiar to you. It will be definitely more familiar if you haven't played around this function before. So the second library we want to introduce is the itertools. It helps you to do a for loop in a nicer way. So it provides us with functions that we can use to operate on a list of iterables and create more complex functions. So using this function from this module helps to create a fast, memory efficient, and readable code. AKA, using for loop is actually slow. It actually, in a way, when you have a long list, it actually slows you down. So itertools actually a better option if you're comfortable using it. So same as the collections, it also has like a counter function. So count, so it starts from printing the start number to the print number indefinitely, and then prints it indefinitely. Cycle prints all the values in the order from the past container. It restarts printing from the beginning again when all the elements are printed in a cyclic manner. Repeat, it repeatedly prints the past value indefinite number of times. If the optional keyword number is mentioned, then it will repeat the prints. Will read the print number of the number a number of times. So so we also have chain. It accepts a variable number of intervals and loops to like all of them one by one. Compresses the function that you can takes in a literal and a selector and returns and iterables with only those items which the corresponding selector value is true. Drop while we will be going through it goes on dropping values from the iterable until it encounters the first element that evaluates to false. So we have also product. We have also product which computes the Cartesian product of the inputs. Permutation, generate all possible permutation from the interval, and combination, combined the contain the past and contain the past in argument and in a specific group in a sorted order. So so that's a very quick theory because we wanted to get you guys hands-on very fast. So if you guys have any specific questions besides I speak too fast, feel free to mention on the Q&A section and the chat as well if you're not comfortable. And then I will pass meanwhile, you guys type in questions, I will pass the screen to Soumya.
Yep, so today's modules that we're following, that we're going to be doing is collections and iter tools. So thank you so much, Karen. That was awesome. So everyone, if you're not following, that's okay. We'll be doing a hands-on coding session. We're going to try out all the functions. So I'm sure everyone's on the same boat if you're new to it. So don't feel like you're left behind or something. So everything will be awesome right once we finish. These are really cool modules, and no matter what you're going to use with Python, these two modules will be really useful along the way. So yeah, so I think Shermaine shared the collab link. All you have to do is save a copy in Drive, and then it'll redirect you to a copy, and we can get coding together over here. So let us know once you have this set up. There are no other requirements today. We won't be using any off the cloud requirements such as your local editors or anything like that. So yep, we'll be using Colab today. I'll just repeat in case you missed it. So all you have to do is save a copy in Drive, and then you'll get redirected into it. Okay. Yeah, I'll zoom in. I hope this is all right. Okay, so let's get started. First of all, make sure you're connecting to the runtime. And so first what we're gonna do is we're gonna we're going to do the collections module. So like Karen told us, it's another built-in Python module, and we implement container type of data types in this module. So a container is basically an object that is used to store different objects. Okay, so we'll first run this. So make sure you're running the first one. We import the collections module using import collections. So the first one we're going to try out is counter. So another way that you can import only counter would be to do from collections, import counter. I won't be running this one because we're going to use the traditional way of importing it, but just for your information, another way to import this would be from collections, import counter. In that way, you can only use counter directly. So now I created an iterable. So an iterable is basically one of those data structures where you can iterate over each element. So I just added a couple of colors. If you were there last week, we added our favorite colors too. I mean, in the first session. So here are a couple more. I kept some of the new colors that you guys have brought in the chat that day. So, oops. Yeah. So we'll run this. We're gonna create our iterable. We have a couple of colors here. Some of them are repeated. So suppose we have a collection of a bunch of people and we ask them their colors. So what counter is gonna do is, counter is gonna create an unordered collection, and it's gonna map each element, each unique element, to the number of times it's repeated. So we're going to do colors counter, and we're going to see how many times each one is repeated. So we see that red has been repeated 3 times, black 3 times, pink twice, blue ones, white ones, and the rest are also repeated ones. So we can do the same thing with the string. A string is also an iterable. We can iterate over each character in the string. So yeah, so it's a random string with the keyboard smash, and we'll count how many times each letter is repeated. So run the cell, and you can see, so you can see that each character is counted and how many times it's been repeated. So we have a lot of popular DSA questions where this is something we should do, and Python gives us an easy way to do it with just a click of a function. Usually it would be better to implement it on your own, but once you get to know what it is and you have to just incorporate the small part into a huge code, you could directly use counter to do this for you, to count how many times each thing is repeated. So we can also use the same for each word. And how we would do this is we would use a split function. And we know that this would return list, if I'm not wrong. So of each word split with the space, split at the space, sorry. So we can also count how many times each word is repeated. So hi is twice, I is twice, there's 1 exclamation mark, and then it goes on. Next, what we do is counter also has a way to, so what we're gonna do here is we're gonna use the elements function, and it returns each element with count repeat repetition. So it would essentially be the same thing we had before, but this time everything will be repeated in a row, and then it'll go to the next one and the next one, and they'll all be together basically. So you just get the thing back, but each element is repeated count number of times. So that's what elements does. And then we have most common. So most common would take a parameter, and you have to specify the how many repeated elements do you want? The top 3, the top 4, just the first one. So we're gonna see the top 3 elements that were repeated. The most common, the top 3 most common color preferences, and these were red, black, and pink. So you can also update the same counter. You don't have to, so like over here, we did collections down counter on favorite colors, right? You can use the update function, so you don't have to run this whole thing again and update colors counter, sorry. So all you have to do is do colors counter dot update, and you can update the new values into it. And now we can see the most common repeated ones again. And you can see that red, blue has been updated into our initial list. So I'll pause for a moment for you guys to soak that in. If you have any questions, you can leave it in the box, in the Q&A box, and then we can move on to our next one. So counters is a really good tool when you want to count how many elements are repeated in any of your iterables. So it can be a list, it can be a tuple, it can be a string. Awesome. Looks like you guys are with us so far. That's awesome. We'll move on to the next one. So it's a deck. So we've learned data structures before. And if you haven't, you can check out Women Who Code had a data structure series earlier this year. So what a deck does is you can remove elements from the beginning or from the end. So we have a queue, right? So if you're familiar with the queue data structure, a queue, what it does is you can add to the end of the queue and you can remove elements from the beginning of the queue. So what a deck does is you can remove and add from both ends of the queue. So from both ends of the data structure, basically. So the way you import this would be, you can directly use collections.deck, but you can also do it this way. And in that case, you wouldn't have to add the collections part, basically. So let's initialize one, and you can initialize it with using any iterable inside of it. So we just put a couple of numbers there. And it gets created. We can check that out with print deck. And it's pretty much the same, but it's been tagged with the data type as deck. And now we can use a bunch of functions that are similar to other data structures like lists and stuff. So you can have append, and a new one for deck would be append left. So append would basically be at the end of the deck, and append left would be at the beginning, so at the left side over here. So we're appending 0 and 12, and then we'll print it and see how it works. So we have 12 added to the beginning, and 0 was appended at the end. We also have count. So we'll count the number of times 2 is repeated. This is also another function that you can see in lists and strings or any other iterable. So we'll count the number of times 2 is repeated in this. And it returns 3. We can see that 2 was repeated 3 times. So another set of functions that we have is extend and extend left. So what we could do is we can extend the deck to the right, and we can extend it to the left. That's another functionality of a deck. So we see, so what I'm trying to do here is I'm trying to put it in ascending order. So when we start adding these elements to the right, which would be at this end, first we get 0.5 added, then 0.1, 0, -3, and then 10. And then the ones to the left would be 13, and then 14 is added, and then 16 is added. So we'll run this, and then it'll be just like we expected. So where we left off last was 12, right? So you can see over here. So 12 was at the beginning and 0 at the end, and we can see that it iterates over this list. So first 0.5 was added, then 0.1, 0, -3, -3, and then 10. And the same way over here. So first 13 was added to the right, then 14, and then 16. So this is just going to give you a really fast alternative for Python lists. if you need to do a fast appending or removing elements, and if you want it done from both sides, this is another really fast way to go. Then we have pop. So I see a couple of questions. Okay, by adding to the right and the left, basically to the deck, so to the list, or I could say, to the right would be at this end, so it's your right. So we'll be adding it to this, and then adding it to the left would be on this end. So it's basically right is saying at the end, and then left is saying at the beginning. There was also one more. Why is blue twice? I should probably go back up there. Once we're done with this, the deck part of it, I can probably go back up there. Shermaine. Okay, I think she answered it. So if not, we'll get back to that. Okay. That was probably in the previous section. Okay, so the next one is pop. So we're familiar with pop from using lists as well. So pop would essentially remove the element from the end of the deck. And we also have pop left. So all these left functions are new added functionalities, which basically define what a deck is, that it's removing elements from either end. So we usually do it from the end, but this also lets us do it from the beginning. So this is our deck right now. It starts at 16 and ends at -10. So we're popping the, just a pop would do it from the right side, and then pop left would be doing it here. So let's see what it looks like. So we see that -10 was pop, and 16 was popped here. Pop also actually removes, returns the element after it's done. So you can probably try doing something like a is equal to deck.pop, and you can print a, and it actually should show you what element that was popped. So you can see that -3 was popped, and this pop function actually returns what it is, what element we actually removed was. Then we have insert anywhere in the deck with an index. So we can insert at index 0, we can add 20. So index 0 would be basically at the beginning. So yeah, this is also a function that we have with lists, and we can also use the same one over here. So the insert by giving the index and then the value. So I'll just write it here so that later on when we get back to it, we won't get confused. Yeah. So reversing a deck is also another a function that it offers, and you can do it by deck.reverse, and you'll see that the entire thing is reversed. So these are the functions that we can use here. I'll just go back to the why is blue repeated twice for a second. Okay, it must be this one, right? Soumya, if you're here, you can probably put in the chat, but if it's this one, it's just me adding blue 2 times to the list so that we can update the count. Okay, so I'll move on. If everyone's all right so far, we'll go to the next one. If you have questions, do leave them in the Q&A. Okay, looks like everyone's okay so far. We'll move on to default dict. Default dictionary is basically the same implementation of the regular dictionary in Python, but the most important part of this is that when you try to find a key that's not there in the dictionary, the regular dictionary would raise an error and it would stop your code. But what a default dictionary would do is it would create that index for you. So this is another way to import default dictionary. From collections, import default dictionary. So we'll try to create a regular dictionary and see what I'm talking about. We're creating an empty one. And we're going to say that I want to increment key 0 with 1. So when I do that, we get a key error because it's not even there in the first place. This would raise an error and it would just ruin the entire flow of our code. What we could do is we can create a default dictionary with integers. So you can send any object over here. You can even say just object. And what we would do is default dictionary of 0 plus equal to 1. It would create the 0 index for us, and then it would increment it to 1. So this is basically what default dictionary is all about, but it's always better to use this one than the regular one, only for this case. When you're trying to implement, if you're familiar with hash maps and hashing, it would always be easier to use this way when you're doing it, because you're just adding like 3 more lines of code, right? If it's not, if there's no key, then add the key and then add the value. Instead, this one line will just do that for you. Any questions so far? You can leave them in the Q&A. Karen and Shermaine are also there to answer them for you. The next one would be ordered dictionary. So what we would do in ordered dictionary is it's also similar to the regular dictionary, but it remembers the order in which we added the values to the dictionary. So that's basically the only added feature. So we'll create a regular dictionary and you'll see that it's A, B, and C. And then we're adding D to this dictionary and we're assigning 1 to it. This is basically still a regular dictionary. So, and it's added to the end, and we added 1 to its value. We're creating an order dictionary now for the same regular dictionary. We'll just add that. And so it's the same thing. It remembers this order that was added. And then now we're gonna delete B, okay? And then we're gonna re-add it again. And we'll see what order it shows. So we're deleting B and we're adding it back again. And then it actually adds it to the end. And if you're not familiar with this fact, a regular dictionary is basically, it doesn't save the order. So dictionary sets, they don't save the order, the regular ones. Right now, when I'm running this, it'll show this order, but another time it could show a different order as well. Or even when you're trying to index it, you can't do regular dictionary of 1 because it doesn't save the order. So yeah, I mean, because it does save the indices as keys, right? So an order dictionary would save the order as well as the other functionalities of a dictionary. In terms of performance, not much, to be honest. So the question was, is there any difference between default dictionary and regular dictionary in terms of performance? So I probably think you mean its efficiency or speed. There's not really much of a difference. The real problem is that the regular dictionary, if there's no index, if there's no key, it's just going to stop your whole program and raise an error. So then you would have to have a try and exception block and work it out, or you have to have an if statement. So it just makes your code all ugly. A default dictionary will create that index for you. So if that's something that you want, it would always be better to use this one. Okay, I hope everything's okay so far. We're gonna do the name tuple now, and this is actually kind of cool. I like this a lot. So what a name tuple is going to do is it's kind of similar to a C programming structure, if you're familiar with the struct in C programming. So what we do in a tuple is that for a regular tuple is just a collection of values, and you can't add values to it once you're done. So you can't, it's immutable, you can't change it, you can't update it, it's fixed, right? And you can index it using 0, 1, 2, and so on. So you can access values through the index. What a name tuple is going to do is you assign it to a variable. You can give it a name, and you can assign all these attributes for it. So you can say that for student, you want first name, last name, their major, and email ID. And these are actually going to be the key value mappings. Basically, it does that internally. So this is how you would declare it. You assign a variable student details, collections.name tuple. For student, we do first name. We want first name, last name, major, and email ID. So we'll run this block. It will declare it. And now we'll create one. So we'll say we want to create student details. And first name is John Smith, computer science, and his email ID. And these will be in order. They have to be in order of the way the attributes were declared. And just a random identification for the variable name. So once it's created, another point too, all of these values can also be different. So similar to a struct in C programming, it doesn't just have to be all strings. One can be integers, one can be string, one can be a list. So when we print it out, you'll see that a student has been created, and his first name is John, last name is Smith, computer science is his major, and his email ID is johnsmith@gmail.com. You can also access particular values, again, similar to structures. You can use the variable name, dot first name, dot last name, dot major, dot email ID. So you can print his whole name using dot first name, dot last name. You can also create another name tuple for this declaration, another variable basically, and you can actually do the mappings yourself. You can say last name equals to first name equal to and acting equal to, but what you have to do is you have to have everything. You can't have anything missing here. It doesn't default it to none. If you actually don't want it to have any value, you'll have to mention email ID is none. But first, let's just see if that is the case. And you'll see that it's missing one positional argument, email ID. So it doesn't do the default mapping to none. So you'll have to do that yourself if you don't want to assign any value at the moment. So we'll just do it. So this is out of order. So if you don't remember the order, but you know the attributes in it, all you have to do is just put an equal to after the name of the attribute, and then you can put the value of it. So now we'll print it out. We'll put first name, last name, and we'll see what the person's major is, and then we'll print the major. So we'll just see what it looks like. So Nick Cage is an acting major. So this is how name tuples work. They're actually pretty cool. You can, and it's another implementation of the structures in C programming. So yeah, and we'll have one more called chain map before we're done with the collections module. If you have any questions, you can save it. I mean, you can send it in the Q&A chat, or if you need me to repeat any part or show something or try something out, if you have anything to ask, you can leave it in the Q&A. Okay, looks like everyone's fine so far. And the last one we're doing in the collections module is chain map. So what chain map does is it maps several it's a collection basically of many dictionaries into one. So it encapsulates many dictionaries into one unit. So let's just name 3 different dictionaries of 3 different people. So one is John, one is Ram, and one is Wendy. We have their email IDs. So everyone has a name and email ID. The first person has an ID. The second person has a list of the classes they attend, and the third one has their GPA. And we'll create a chain map. So it just puts all the dictionaries into one unit, a dictionaries basically. And now we'll try to print all the keys in this chain. So you can see name, email ID, GPA, classes, and ID. One thing you should notice here is that we have name, email ID, and ID for the first person, and email ID again, and name again for the remaining. But it's just gonna pick the first one that repeats in all of the dictionaries. So it's just gonna pick this guy's name, just gonna pick this email. It's just gonna pick this guy's classes and this guy's GPA and this guy's ID. So that's one thing that this chain map does. If you see all the values, you will understand what I'm talking about. If you just pick the first name, I mean, the chain map only picked the first name of the first dictionary that was added. So in the order that it was added to the chain map, the first person's email ID, then all the remaining ones followed after that. If you want to see all the values in the chain, we do chain.maps. So one thing about chain map is it also implements all the dictionary functions as well. So .keys, .values are stuff you see in dictionaries. So you can use those in chain map as well. One additional functionality chain map has is maps. So you can see all the values in the chain using that. So this seems pretty useless, right? If there are repetitions, we can't actually use it for this case. For this case, it would be cooler if we use a name tuple. But what we could use is if you have a store and you want to do an inventory for that, you can have a list of dictionaries. So you can have pens, notebooks, rulers, calculators, erasers in your store, and you can have a chain map of that. So this is kind of like implementing a linked list. It maps pens and then it has notebooks. So it's basically a series of pointers to all of these. So we're adding pens, notebooks, rulers, calculators, erasers, and it doesn't actually make a copy of all of these in its own. It actually points to all of these individually. So let's create a store inventory where we have a stationery store. And we're doing an inventory of all the pens. It has all the types of notebooks, rulers, and calculators. We'll see what items we have in our inventory. So you can see that it'll print all the keys. So that's one use we can do with keys. We'll see every item that we have. Now let's see if you want to see how many wide rule notebooks of 175 pages you have, all you have to do is directly index wide rule 175. If we did that in the previous case, we would only get John if it was for name. Since over here, we would always have unique values for an inventory. You can directly index it this way and you will get an answer you need. So we have 200 wide rule notebooks. You can also do that for basic erasers. We only have 5, and suppose someone's trying to buy all 5. You can directly do that on erasers as well, and it will reflect in the store's inventory. So we're removing it from the erasers dictionary. So this one, and you'll see how it actually points to erasers, but doesn't make a copy in its own. So we're removing all the erasers, and we're gonna print the inventory of that, and we see that there's 0. So another function that we could use is get. That's also there with dictionaries, and we'll see if we have folders, and we don't. So it says it's none. So you can actually add it now. You can use the new child function, and you can add folders into the inventory. So we'll say we have ring folders and we have 15. And then if we add it in, it adds it to the beginning. So whenever we're adding a new child, it'll add it to the beginning of the chain map. So this is collections. If you followed so far, let us know. If you want us to repeat something, let us know. Let us know which one you like. So we did 5, right? We did chain map, we did name tuple, ordered dictionary, default dictionary, a deck. We did counter. So let us know which one you like the most, and then we'll move on to other tools. I don't think there is a limit on how many dictionaries that you can add to a chain map. Python usually doesn't have the overflow problems most of the time, so it should be okay. But I'll make sure I check and let you know. But usually there isn't a problem with that. Okay, so we'll move on to the next one. Maybe before that, we'll take a short, interaction. We'll see which one you guys like the most. So do let us know which collections functionality you guys like more. Mine, like I mentioned, it's name tuple. What about you, Karen?
I recently used a lot of default dictionary,
Uh-huh.
so that would be my favorite for now.
Shermaine, do you have a favorite?
I think Shermaine is like maybe a wave of it, but like counter is
Yeah.
very convenient. It is very it's interesting that like I maybe give some time people type questions. It's interesting these two, it seems like very like common, like
Yeah.
it's like kind of, but like it's like super powerful when you need them, instead of
Uh-huh.
writing like 20 lines of code, you can just use one function. It's amazing. So
Yeah. Sonia, if you need us to repeat anything or clarify something, you can let us know. If you do want to brush up on your basics, there's also another study group going on called Beginners Python Group. You can check that out. We also have a playlist on YouTube. You can join us on Slack and you can contact us and ask any of the questions you have. Don't feel intimidated or anything. Um, these are pretty cool once you get the hang of it.
also, if you guys need like the material, for example, like the theory part, like I ran it really fast today so that we can go on to the practice section. If you have any, like if you want to like review it after you get more familiar, or like there's like a project that you suddenly think like, oh, we need this, like, so feel free to go to the GitHub website. So
Yeah.
we have
So
all the materials posted
mhm.
there, so you can review it anytime.
So we'll keep updating this as the sessions go. So you can feel free to check out the repository we have for this series, and you can do it at your own pace. We also have we'll also upload this on YouTube. Uh, Not really. You can actually just
You can
take this link
start it,
and
I guess.
yeah, you can start, or you can check this link out. You can
Yeah.
clone it to your local machine. Yeah, so you can follow the YouTube video later on as well if you want to revise what happened today. It is a lot at once if you're especially new to all of this. But yeah, don't feel intimidated at first. It does feel that way. Uh, you can always go through it later as well. So if you guys don't have any other questions, we'll move on to the next module. It's iter tools. So this is another really cool module that we use in Python, and so it provides us with functions, and we can use these to operate on iterables, and we can actually create more complex results from that. So we import itertools with import itertools, and the first function we're going to try is count. So these are actually infinitely looping functions. So they're indefinite. So what count does is we mention a start and a step. So it starts printing from whichever value we mention for start, and in steps of whatever we mention for step. And it actually goes on infinitely. So you actually have to have a break in between, or at least an if condition on where to stop. So we're just gonna print out 1 to 100, and we're actually gonna start from 0, and we're gonna print in steps of 10, and we'll stop once we go over 100. So as you can see, it prints 0, 10, 20, 30, 40 until 100. And once we reached 110, it actually came out. If you actually don't leave this, it's actually going to loop infinitely. So that's count. The next one we have is cycle. So what cycle does is it takes an iterable, and it prints every element in the order that it's present in the iterable. And then it cycles back to the beginning and prints again. And this also goes on indefinitely. So until you actually put a break or a if condition in between to stop it, it goes on forever. So we're going to have a series of vowels, and we'll actually have a flag to stop it once it reaches a certain count. So we'll print. So what you're going to do is itertools.cycle, and we add the vowel, and then we print whichever value we're at, and then we're gonna print a flag so that once we reach 9 elements, we'll just stop there. So as you can see, it prints A, E, I, O, U, and then it cycles back to the beginning, starts printing it again. There's actually another way we can do this. So we can use next. So we can iterate through the whole thing. We can say that we're iterating over it twice, and we can just print the next one. So next is usually a function we use on iterables. So we save the cycle in V, and then for 2 iterations, we'll print the next value. So as you can see, it'll be A and then E, and then it stops because we're looping for 2 times. So next is kind of like it's like a pointer, and it first starts at the beginning and then it goes to the next one. So these 3 were functions that go on indefinitely. So count, cycle, and but we also have repeat, sorry. So repeat also goes on indefinitely. So yeah. So what we're gonna do is we're gonna repeat 1 5 times, okay? And if you don't mention 5, it's actually gonna repeat forever. And we're gonna add these values into a list. So as you can see, it was repeated 5 times. We can actually try and see this, and it actually go on forever. So it should actually cause a problem. And as you can see, it's actually going on forever. It's adding it to repeated nums too many times. Well, should probably stop it. Okay. Okay, our session crashed because it went on for too long. So let's try not to do that again. So if you did the same thing I did, your Colab must have restarted. So try to import itertools again. So yeah, repeat is also something that goes indefinitely, and you have to mention how many times you want it repeated, or else it'll just go on for infinity. That's why we got a runtime error. You can also do the same thing. You can save it in the string, and then you can iterate over a string and print every word in it. So, and then it prints it twice. So like I said, repeat, cycle, and count they go on for infinity. They're infinite iterators. Okay. Why does it say flag in one example and range in another? Okay, so over here we're using flag. You can actually call it counter as well. So it's just a counter to see how many times we're iterating. Okay, so we're just increasing the number, we're just keeping a count. So this is on us. We're counting how many times we're repeating it. Over here, range is a function that we use, and it starts from 0 and it goes on to this number. So this is the end. So this is start and end. So when you start at 0, it's first 0, then it's 1 the next time we loop, and then at 2 it stops and comes out. In repeat, so what we can, okay, so we can do this, and we can actually do the counter thing again, if I'm not wrong. So counter is equal to 0 for I in repeated nums. If counter is equal to 3, great. And then we'll print I, and we'll print it in a line. So we'll use end is equal to space, and then we'll increment our counter. So this should work like how we did it before. Oh, sorry. Yeah. So our runtime error actually came because I was trying to print all those infinite values, and that was a problem. So you can actually do the same thing. We're actually saving it in this, and then we can use a break statement. Okay, so we'll move on to the next one if everyone's all right. The next one is product. So over here, the next three would be combinatorial iterators. So product, permutations, and combinations. These work on combinations basically. So iter_product computes the Cartesian product of whichever iterable we're giving as an input. So let's create a set of 1, 2, 3, and 5. And a Cartesian product basically, it maps each element to all other elements. Every single combination that's possible, that's a Cartesian product. So it maps to itself, it maps to every other element in the set or list or anything like that. And we mentioned repeat. This is how many times, this is the size basically of our the subset that we're creating. So we'll take a look at it first. So we're declaring the size as 2. And we're taking a Cartesian product of it. So we're mapping 1 to every element in the set, and then 2 to every element in the set, and then 3 to every element, and then 5. And we want it 2 times. So you can also do 5. Okay, not 5, but we can do 3. And it'll be 1, 1, 1, 1, 1, 2. And if you don't mention anything, it'll take in the size of the set itself. So, okay, basically it'll just take one element, sorry. So yeah, if you don't mention anything, it'll actually take, looks like it'll just take 1. Yeah, so it's just going to take 1 by default, unless you specify otherwise. The next one is product. So what we're so it's another one of those combination functions that we use. So it's like ax b, if you're familiar with. Oops. So it's kind of like ax b when you're doing those computations, when you're doing the combination permutations and all. So it's a product basically. So Cartesian product. Oh, this is okay. It's the same thing as before. Sorry. Yeah, A into B is basically Cartesian product. So we're doing Cartesian product of A and B. So it'll map A to every element and then B to every element. So as you can see, 1 into A, 1B, and then 2B, 2A and B, and then 3 Cartesian product with A and B, and then 5 with A and B. Okay, so this is the product of it. So this one maps it to itself, and then this one is a Cartesian product with of two different iterables. And then the next one is permutations. So permutations would generate all possible permutations of the iterable. So every possible permutation of this is what is generated using iterables dot permutations. So you can see it'll be A, B, C, D, and then A, B, D, C, and then A, C, B, D. So every permutation, and over here, it has a repeat parameter basically. So if you don't give anything, it'll take in the size of the entire iterable. And if you do mention it, you can mention the size you want. And if you mention 2, it'll give every permutation of size 2. All right. So the next one is combinations. So again, it prints all the possible combinations and with the group size. And all of the printing actually happens in alphabetical order or in a sorted order, basically. So even for permutations, it prints it in a sorted order. If you can observe carefully, A goes first and then B. So the same thing here, maybe so we can understand it better. We'll just put 2, 1. 3, and then we'll see if it actually prints in a sorted order. So we're doing a sorted order of all possible combinations of size 2. So the difference over here between permutation and combination is in permutations, A and B is different from B and A. But in combinations, A and B is the same thing as B and A because it's still a combination of A and B, right? So it didn't print it in sorted order. Well, that's sad. I'm sorry, but it's probably because it's first considering which order it was in this, which order the elements came in, and then it's doing the rest with sorted order. So probably the second value onwards, it takes in the sorted order, but the first element is actually what element order it came in. So you can see that the difference between the permutation and combination here is that this takes 2 and 1, the same thing as 1 and 2. And then so that's why you see very few over here, because every other permutation doesn't work the same with the combinations. So these 3 are the combinatorial iterators. And then okay, there are no questions so far. That's cool. The next one we have is chain. So these are finite iterators, basically. So what we're going to do is chain actually accepts a multiple number of iterables in it, and then it loops through each and every one by one and in the order that it was added. So it basically just creates a chain of all the iterables that were added. So first 1, 2, 3, 4, 5, and then all the vowels, and then the vowels in lowercase. And then we have compress. So this one's kind of cool. So what it does is it takes an iterable and then it takes a selector. And what it does is we actually map each value to the selector. And if it's false, it doesn't select it. And if it's true, it selects the value and prints it out. So we're gonna print out even values. So the first one is 1 and we gave it false. Then 2 is given true, so we can print that. 8 is given true. And then at the end, 10 is given true. So it actually maps these values to this one. So it takes in nums and true and false. And then it prints out the values whichever have true assigned to it. And the last one that we have here today is drop while. So it takes in an iterable, and it also takes in a function. We're doing a lambda function here. You can also define one up here with the def function name. So what it does is, for the iterable, it drops every value that we have until we get false. So we're doing a small lambda function, and a lambda function is basically an anonymous function, and you can actually just declare a function in a line. So it's just a one-line function. So what we're doing is lambda is the keyword for it, and we're taking the input x, and then you put a colon, and it's and return whichever value, whatever works for this. So you take an x, and if x is not equal to 0, then it's true. And if x is 0, then it's false. Yeah. So what we're supposed to expect is, until the values are true, it drops all of them, and once the value is false, it starts taking all these values in. So we start printing from 3 and 0, and then 3 and 2 and 1. So this is what it does. So while true, it drops everything, and then once we encounter false, it starts printing everything else. So that's it for today. It was a lot to take in, but you can actually go through the material later on. You can check out the collab again. We'll upload it to the Git repository. Any time of the day, you can contact us on Slack, and we'll answer all your questions. So a couple of useful links. We have the link to the Git repository. We'll share it again in the chat. We'll probably upload everything by today or tomorrow. The Git repository also will have the link to the video. We'll add it there. We'll also share it on Slack. You can also find the video link on YouTube. Thank you, Shermaine. And we also have a couple of links for reference. So the documentation in Python is actually really cool, and it's well written. So you can refer to those and a couple of other additional resources as well. And upcoming events in this series, we have mathematical computations. So we'll be exploring random, math, and statistics. And after that, we'll be doing regex and string. And then we'll start with a new series with data visualization, data science, and analysis. So we'll be starting off with NumPy and Pandas libraries. And more events in our series. We have Beginner Python Study Group coming up on the 13th of next week. And we have the next 2 weeks with our Python Libraries 101, and then Beginner Python Study Group again on the 27th of August. So do make sure you sign up. You can find all of these events on Women Who Code Python. So thank you for joining, everyone. I hope you liked today's session. It was a lot, but